All right, this next problem here is going to be probably a culmination of all the different smaller concepts that we've done built up to. We're going to be looking for the resulting vector of two other vectors. And we used ohms here for the units for our magnitude, just to give you a little preview on some of the AC theory to come. Now this is probably one of the most complicated ones we'll see in advanced math, so if you guys can work through these, you should have no problem moving forward. But when we get into AC theory, this is just going to be a step in some more complicated problems that we're going to be solving. So we're going to keep building and building, and as soon as you get comfortable with one thing, we're going to stack something else on it. So here we go. Let's look at this one. So in this problem here, we have vector A and vector B, and we're going to add them up and find the resulting vector. Now, a couple observations we'll make. When we previously found the sum of vectors, we had to add their coordinates, right? And now we don't have coordinates. We just have a magnitude and a direction. And then we also did some homework where we took a magnitude and a direction and found some coordinates. And then with those coordinates, we found the resulting direction or angle. So we're going to take all three of those concepts and put them together here to just solve this one problem. So I got two charts here. One I like to use as kind of what I call my sketch chart. So I can draw my triangles and my vectors roughly to just get an idea on my SOHCAHTOA information, which ones are my opposites and adjacents, and make sure I draw them correctly. And then a lot of other times I'll have my scale drawing where I actually write everything down to scale just to kind of get an idea, because if you have two vectors that you draw in there and they're pretty close to scale and you see one's going this way and the other one's going in the same quadrant, and all of a sudden you get a resulting vector that's shooting off this way, you know that's not going to be right. If you have two vectors that are approximately in the same direction, the resulting one should be even further in that direction now. So let's erase all this junk and get started on sketching these out and seeing step by step how to solve these. So vector A, I have a magnitude of 4 ohms and a direction of 320 degrees. So we got another pesky direction angle that is not within 90, so we got to figure out what that means. So again, out of 360 degrees, that 320, I can already tell it's probably going to be somewhere in this category since it's over 270. So I'm going to go ahead and make my rough sketch in that quadrant. If I take 320 and subtract 270, which is going to bring me 90, 90, 90, all the way down to here, I can see that I'm going to have a 50-degree angle. So 50-degree angle with my vector is going to be right here. And I'm going to make my triangle kind of like that right there. Now, if you had 50 and you wrote that 50-degree angle in here, that's going to be wrong, and it's going to flip-flop your opposite and adjacent when you go to plug those in with your SOHCAHTOA. So just make sure you're putting that angle where it belongs. So let's just label that so we don't get mixed up. We got vector A, and the other one is going to be vector B, which is going to be 72 degrees up in this direction, and it's going to be a direction of 72 from the positive x-axis up to this vector. It's going to be 72 degrees, and that's going to be vector B. So the magnitude of vector B is 12, and the magnitude of vector A is 4. And in my triangle here, those are going to be the hypotenuse of both of the trig functions I'm going to process. Okay, so let's go ahead and find the sides of these triangles, and then we'll look at what does that tell us about the coordinates of those vectors. So the sides of this triangle up here in vector B, my hypotenuse is 12, my angle 72. I have my opposite, the 72, and my adjacent to the 72. And I'm going to need to solve for both of those. So if I have 72 degrees, sine is going to be my opposite over my hypotenuse, right? SOH, sine equals opposite over hypotenuse. So I have the degrees, 72 degrees, equals the opposite, which is unknown, over the hypotenuse, which is 12. With a little bit of cancellation to isolate our unknown variable, I can see this comes down to 12 times sine 72 equals the opposite. So plug that in, 12 sine 72, and that gives us an opposite of 11.413. 11.413. And I'm going to do the exact same thing over again with cosine to find the adjacent, right? Because sine 72 was for the opposite. Well, cosine 72 is going to be the adjacent over the hypotenuse. So we'll kind of be doing the same thing here. You can even start to see a pattern there. You're going to be able to skip some steps later. But just to solve it out, we're going to cancel the hypotenuse, which again is going to bring the 12 over to this side of the cosine. So we're going to have 12 cosine 72 is going to equal our adjacent for vector B. So 12 cosine 72 gives us 3.708. And now I have the sides of my triangle. So with those sides, I got to figure out what that tells me about where my coordinates are. So up in this quadrant, I know I'm traveling 3.708 in the positive direction of x and 11.413 in the positive direction for y. So the coordinates for vector B here, vector B is going to be 3.708 for the x, and the y is 11.413. Now don't forget that these are in ohms, so we'll keep our units when we get to the answer, but I'm going to save some room here and just write the coordinates like that. So we have the coordinates. Now I can kind of make my more to scale sketch down here on this graph, just to help me kind of double check myself and make sure everything kind of makes sense. If I have a bigger, which I see I have a bigger magnitude heading in the positive direction up on top, and a smaller in the down below. So that one's going to be my greater force that's going to influence where my resultant vector is. So I'm going to go ahead and go over 3.7 approximately and head all the way up to 11.4. We'll just say that's right here. And let's go ahead and label that. So that's vector B, right? Vector B. Now vector A, let's go ahead and solve that triangle. So we have a magnitude of 4. So if we have 50 degrees and we want to find this opposite 50 degrees and then the adjacent of the 50 degrees, we're going to do the same thing we did before. So we're going to say, okay, sine of 50 degrees equals the opposite unknown value over the hypotenuse of 4. Some cancellation. We're going to get 4 sine 50 equals the opposite. And we're going to say that the opposite equals 3.064. Now for the adjacent, cosine 50 degrees equals the adjacent over 4. Cancel that out. We have 4 cosine 50 equals adjacent 4 cosine 50. And that gives us 2.71. So the adjacent 2.71, no, sorry, 2.571. 2.571 for the adjacent, and for the opposite, 3.064. So what does that tell us about our coordinates? So for vector A, we're going to head positive direction, 3.064. and in the negative direction of y, 2.571. So now I can go ahead and add these together, right? I have my coordinates. Let me go ahead and sketch the vector A down here just for reference. So I got 3.064, so just about 3, and then negative 2.571. So I'm going to be around here. And that's going to be vector A. Now, just based on the trends you see in vectors, I shouldn't get a vector shooting off this way from those or shooting off this way. It's going to be somewhere a combination of these two. So I'm guessing I should be somewhere in here before I even do any math. But let's go ahead and find out. So if we add those points together, we're going to say 3.064 plus 3.708, and that gives me positive 6.772, and for my y value, I have negative 2.571 plus 11.413. So let's see what that gives me. So I have 8.842. Now notice that's positive, right? We had a smaller negative number here, negative 2, and we added 11 to it, so we got a resulting y coordinate of 8.842. So these are our coordinates of our resulting vector. Now I'm not going to write that in here because that's not my resulting vector. These are just coordinates. A vector is a magnitude and a direction, right? So I'm not done yet. I need a magnitude and a direction from these two, the sum of these two vectors. But I can plot these points and kind of get an idea on where that's at. So let's go ahead and do that. So 6.772 on the positive x and 8.8 positive on the positive y. So I want to be somewhere right around here, which that's kind of where I thought I'd be, right? Because both of these are going the positive x direction, so that increased. And the bigger one was heading up in this direction. So this is going to be vector AB. Now, what I need to do is find out what is the magnitude and direction. So I can create a right triangle here. And let's go ahead and see what that would give me. What would that right triangle tell me? Well, I would be able to find out the direction, right? I'll be able to find this angle here. And with the two numbers I have here, I can write that in and see that that's going to be my sides. So using Pythagorean theorem, I should be able to find my hypotenuse right there, which will be the magnitude. So let's go ahead and take these numbers here and plug that into Pythagorean theorem. Those are my sides. Doesn't really matter what order I put them in. They're the two sides of the triangle. So a plus b or b plus a. I'll just say that 6.7 square root of 6.772 squared plus 8.842 squared. So that's going to give me a hypotenuse of 11.137. So that's my magnitude. So in here, I can write 11.137 ohms at, and what I need to find out now is the angle, the direction this is going in. So luckily in this quadrant, I'm not going to need to add any 90 degrees or 180 or 270 to it. It's in quadrant 1. So calculated from the 0 positive x-axis here, whatever angle I get here, that should be my overall direction. So since these are my most accurate numbers, since I started with these and I rounded the hypotenuse, I'll go ahead and use these. And what I can do with that is I know that that can be my tangent, opposite over adjacent. Now, which one of these is opposite and which is adjacent? Well, let's take a look. So the 6.772 is the x, so I'll write that in here, 6.772, and the 8.842, that was the y. So based on my perspective here, looking for this angle, my opposite is going to be 8.842, and my adjacent is 6.772. So I'm going to be using tangent. So tangent, let's see if we can erase some work here to go ahead and make some room. I know that tangent of theta, our unknown angle, is equal to opposite over adjacent. So tangent of theta is 8.842 over 6.772. Now I need to get this angle by itself, so I'm going to isolate tangent and get the inverse function of it. And let's see what we get out of that. So inverse tangent of 8.842 divided by 6.772, and that gives me 52.552 degrees. 52.552 degrees. So this is the resulting vector, 11 ohms at 52.552 degrees. And based on our chart here, we can kind of see that that does make quite a bit of sense. We have a really large magnitude heading up, a smaller one heading down, but both heading in the positive x direction. The resulting vector is bigger in the x direction, but it's kind of in between these two other vectors that created it. All right, everything seems to check out, so go ahead and work through it, and we'll give you guys a couple of sample ones like this to take care of.